Start.
Oh, hi. Welcome, everyone. Today, we're going to talk about next generation observability, leveraging AI and data pipeline. And I am Sarav, Director of Cloud Infrastructure and Observability at Informatica. And I have Kirti with me, who is Infrastructure Architect at Informatica. The agenda for today is establishing the problem statement. What is the current problem we add at Informatica and our existing telemetry pipeline and our futuristic next generation telemetry pipeline, how we embedded AI in each part of the telemetry pipeline, using the cost and bringing better MTTR. So Informatica, right? Informatica infrastructure, we operate on four different cloud providers, hyperscalers, Amazon, Azure, GCP, and Oracle, spread across 20 different regions, 600 and more Kubernetes clusters, and several thousands of worker nodes and virtual machines. We ingest about 60 terabyte logs every day, with 3.8 trillion documents get ingested every month. And if you look at our storage, it's of 15 petabytes on S3, and on EC2 virtual machines is about 2.5 petabytes. So given the scale we operate, and given that we operate in different cloud and different region, it brings its own challenges in cost, compliance, and operational aspect of things. Right. The source of logs come from different region, different availability zones, get consolidated into one centralized message queue, which we currently use Kafka, and ingested into the data store and visualized using multiple tools like Kibana, Grafana, and homegrown analytics tool. So this in turn increase the cost, operational expense, and slower dashboards with the amount of data we operate. So this problem make us to rethink on our existing observability pipeline and come up with a new pipeline, bring Gen AI and ML flavor in each stages of the pipeline. So we bring things into the source. So consolidated the collection using open telemetry and bring filters and ML models at the source, so we can clutter noisy unwanted data and declutter them in the source itself. So we reduce right in the source 20% reduction and move the data to the centralized message queue with better optimized pipeline, producing 50% saving right there, then ingested into data storage. Throughout, by doing so, we reduce noise right in the source, more in the left, and using AI and ML models, we are able to apply better control of the data, bringing clean compliance result for us. As the data ingestion reduced at the source, we also reduce storage cost, backup cost, and quicker dashboard instantaneously available to the end users. So with that, I would like to have Kirti join me to go a little deeper into the architectural pieces of this telemetry pipeline.
Hey, thank you, Sarav, for this great overview. Yeah, so as Sarav mentioned, we have been dealing with a huge infrastructure which ingests a lot of telemetry data, and it's actually massive. We have to operate at massive scale. So what we did is to control, to get a control over this telemetry data, we have implemented something called telemetry pipeline. So we first started with the centralized telemetry pipeline because observability is very much important to every piece of the application and infrastructure. It is being used by application security for every purpose. And today's world where there is a lot of vibe coding, AI is generating your code. So it's very important to make sure that your observability is in right shape so that in case there is an incident, you have the right set of data to troubleshoot. So what we did is, since our system is getting more and more telemetry data, so we put this telemetry pipeline to make sure that we are ingesting only the actionable data that is required for us, and we need to store that for longer time. So by doing so, by adding a centralized telemetry pipeline, we could able to reduce our logs. But what we realized is the majority of cost is coming from the edge collectors, from where we are collecting the logs and sending it to the centralized system. So we started using a open telemetry based agent where we can add filters to filter out all the noise at the source, so that we don't have to send them through the network where we incur a lot of network transfer or NAT gateway cost. And once that data comes to our centralized telemetry pipeline, so there we massage the data on how we want to send them and how we want to store them. For example, sometimes there are a lot of logs people are sending which they are using for metrics. So, but logs are quite expensive. So with the telemetry pipeline, we can convert them to metrics and store it in metrics system instead of storing it in the logging system. So similarly, there will be a lot of health checks or similar kind of things where probably we may not need all the raw data that is coming into our system. So what we can do is we just need a summarized version of the information which will be useful for us. So in that case, what we can do is use the telemetry pipeline to downsample the amount of telemetry that's coming in and write less data to the backend observability system, which is more useful. So with this, what we achieved is we reduced the telemetry noise and we got better control over the data. For example, if there is a lot of logs that is having some kind of PI data or something, so we have a central place to manage that, basically add some kind of masking on top of it before we write it for a long-term storage. So what happens with the less data coming into the system, our dashboards are running faster, the cardinality of the telemetry is reducing, and also it's increasing our search, which is giving a good user experience. So this is kind of gave us more control over the data, but it also introduced more human effort to maintain this. So to create the telemetry pipelines, to maintain these pipelines, and also to keep the track of all the different patterns that's coming into the system. So what we did is we leveraged AI to solve that problem. So with AI added to our telemetry pipeline, so we implemented one AI agent which takes your natural language query and it knows what are the transforms and what are the pipeline query languages. So it can create new pipelines, it can manage existing pipelines, and also based out of the structure of the data or the pattern of the data, it can recommend you basically if there is any scope of optimizations that you can take any action. And at the same time, we are not completely adding AI agents to create our pipelines. We are also keeping human in loop to review and approve on the suggestions that's given by the AI agent. So once the human reviews and approves it, then AI agent goes and deploys it. So that way, there is less resource required to maintain and build these pipelines. So with less amount of data, we are able to get better observability systems built on top of it. So this is how we operate. Basically, we have a single unified hotel-based agent which collects all the different telemetry signals, and these agents are managed with fleet management, so we don't have to go through each edge location for any configuration changes. So that makes our configurations redundant as well. And all our applications are basically they're instrumented with different APM. So with those instrumentation, it helps us to propagate the context about all the API calls that's traveling from service to service. And with that, we are able to create these different service maps and correlation between services. So this helps us reducing a lot of toil during our investigation of any issues. And moreover, you don't need an expert to be present in all the investigation calls to go through how the service is behaving and how each service is basically correlated, or when when is service A is calling service B or it's calling service C. And also we have implemented some ML models to detect the anomalies in the system, so that we can alert in case there is some kind of, let's say there are the API response is high, or maybe there is some errors that has increased in a particular service. So with all these things we have, it required massive efforts from, human efforts to maintain all this thing. So that is where we have implemented our AI assistant. So this is again another AI agent where you don't have to really understand the different query languages that is required to build your dashboards or get the required data whenever investigating any incidents. So you can just go to the AI assistant and ask what you need in a simple natural query. It will convert that to the query language that the observability system understands. It it goes through your observability system, it correlates your traces, metrics, and logs, and it can provide you basically basic visualizations which will help you to understand what's going on in the system. And also it can help you to automate some of the books. It can run some of the run books to do regular maintenance tasks that is also required, whatever is required, some human efforts. So this is the way we have leveraged AI in our observability to reduce the human efforts that is required to build and maintain these systems. And at the same time, we are also making sure that the observability stack we are running, the cost is within the range, and also at the same time the user experience is good. And also whenever during incidents and all, whenever people need some specific data, then they can easily get that instead of depending on others or searching for which dashboard or which query to run it. So this is also reducing our MTTR of our incidents. With that, I'll conclude here. So thank you everyone for tuning in. Thanks everyone.
Thank you everyone. Thanks, Kirti.